跟着他说下一页，我给你下一页。
Next one.
Next
You'll
picture.
change this.
If you say next, then
Okay.
we'll change it.
Nice to meet you.
Yeah, nice to
I'm
meet you.
Manik.
Yeah, that's the picture.
Today we have a plan to present my research.
Excuse me, Malik. I think you stand the other
Yeah,
side.
that side.
Yes.
Yes.
So make your face.
Camera.
开始了吗？是吧？快点，你要说 action 啊
Action，他说
You can say start.
！One, two, go！
So this.
Go.
This side is okay?
Yes.
Yes.
Okay, nice to meet you. I'm Manik. We are present showing some special technology of heat pipe. So heat pipe is a very big field of technology. There have a lot of applications. Every year we use different modifying the technology every year. The whole the world the research is so bright and so high. In this case, our company also working for modifying and advanced technology to improving day by day. So now we are working for the creative innovation of quick structure of for the heat pipe technology. Heat pipe is an efficient and cost-effective thermal management solution. So now we are going to work for heat pipe. Heat pipe, inner and outer, they have a lot of work and technology. We just explain now. Okay, go ahead. Next. Part of heat pipe product analysis. So we have content here, the part 1, part 2 and part 3. Part 1 is the product and the applications, technology and software applications, and level of product standard quality. There are 3 issues I'm going to explain now. So this product and applications is the first part that we are going to explain. The next one. The part 1 is the product and applications. The computer cooling system is the most used in the world. Computer is necessary. If we have the computer, all computers have the cooling system. If we don't use the cooling system, computer will shut down and burn. So it's very effective technology for cooling. And then medical equipment is the same as the laptop. Industrial machinery cooling parts is the most efficient. And transportation vehicle cooling system, each and every transportation up to car, truck, bus, vehicle, aircraft, space, and rocket, satellite, each and every vehicles we must use cooling system. That means heat pipe. Heat pipe is the best and effective technology for cooling. Then aerospace thermal control, that is I have said, the aircraft cooling system, flight data recording, this is also more creative. The green energy is going up, and next generation they are following the new energy, the green energy, thermal energy production plant. This is most useful for the heat pipe. Next, the computer heat pipe and heat sink. We always care about the computer cooling. How about the cooling? Cooling condition is better, then computer life is good. If computer life is better, our work is good. So we are so careful of cooling, heat sink and heat pipe. Each and every computer we must use heat sink, heat pipe. So before we have seen that only using just heat sink, but now recently we use heat pipe. So this heat pipe using computer making better life. The cooling system, cooling solution, we're getting the most effective way. And then next, you can show him the other part. Next. Next. The industrial machinery is heat sink and heat pipe. We used it. The industry, machine cooling, and the machine parts, CNC machine, a lot of the thermal power controlling, cooling control. We have to use mostly the heat pipe. Inside have the fluid, water, ammonia, nitrogen, something else. We use inside the fuel, some fluid, working fluid. That's the thermal engineering, we can say the working fluid. This fluid using as a cooling control, cooling management, cooling solutions. We use here also same as that. It is also using heat sink. Various materials. We're using aluminum, copper, also titanium. Most of thermal solutions we use heat sink, mostly copper for pipe, aluminum for heat sink. And next. So we are going to big place. That is the aerospace and Chinese Hong Kong Hantian. So it's very big issues using heat pipe, the copper heat pipe. This heat pipe using the satellite, also the heat pipe here. So this is heat sink, as same as the aluminum and copper heat pipe. The same as here, heat pipe, aluminum heat sink. The same pipe in satellite is upper. And then this is the sun. Sun making heat, high temperature. Is more than 200 temperature, 200 centigrade temperature, forcing daytime for heat. And this heat on the surface of satellite, it will be more hot. And this hot effect, the solutions, only way to low heat pipe is a shortening LHP, low heat pipe. The same as this hot side, this is sun. And the when sun is the heat on satellite, it will be hot. And that side is cold. This is a cold. This is the earth. This is the sun. The temperature is management by low heat pipe. Continue. Inside is water, ammonia or nitrogen that can control solutions using low heat pipe. Is the best and effective technology in the world for each and every vehicle. So we are going to next. Next. The Co. F-35 jet aircraft. The crane group. We find out airplane using cooling systems also the same as the heat pipe. This heat pipe using titanium or copper and aluminum. The material is, it doesn't matter the effect on the materials choose and method, but mainly we are using that. We are focused on this. This heat sink using this metal. The metal would have the showing applications here. This application is fluid, and then you can get in the result. So this is aircraft wing. Aircraft wing also using heat pipe. Copper. And next. This aircraft is a black box. We know the flight data recorder. The flight data recorder, the black box is here, using heat pipe. And they have memory storage is here. After the crash, the craft, then we find out the box. And we take the memory and we know how to, what happened before the aircraft is crashed. And we are finding information from this storage. And then we know what was happening and how we get the solution. And next accident will not be happen. So these issues is also very effective technology using here heat pipe each and everywhere. So we should just explain that very basic issues. That is so deep issue, very explainable, but it's very complex. I just explained basically that why are we using heat pipe in the different vehicle. And next, and the green energy and thermal energy also the same producing plant also using same heat pipe. This heat pipe is different. This heat pipe also the spacecraft is the same. The loop heat pipe, the LHP, cooling, heating, the vapor, liquid. So these issues is a fluid simulation. So this evaporation, condensation, the process, heat pipe, pressure pump. This is different. This using for the solar panel. This is a solar panel using for power by sun, temperature, hot, then absorption, the energy to producing electricity. So this is the heat sink using copper, using aluminum. The heat sink used also with solar. So they have also the heat pipe is inside, copper heat pipe. And next, the part 2 technology of software applications. The weak structure and PCR method analysis, the porosity, permeability, pore radius, thermal diffusions, surface weightability, and the evaporation materials. We have a lot of specific issues to see CAD solution, and we also CATIA, we also CFD, Fluent, different simulations method, and lastly we're using for MATLAB for some final result. We have to calculate, and then we can getting the right technology, what we have the good result. We can get this. We find out the right answer after all process. This is the shortly explained here how is a heat pipe technology process. And next, that's the internal technology of heat pipe, PCM, structure of center weight of heat. They have a lot of issues. I have to explain very basically, very short, that basically you know that three kind of use of a weak structure. That is the weak and the grow weak, and this also is grow, sintered, and mesh. So just here showing different kind of weak structure. The weak structure and sintered weak is a main function of heat pipe technology. Each and every heat pipe have inside must using first media. The name is PCM. Next we are going to explain the PCM. Next. And now weak structure of heat pipe using for grow, mesh, sinter. So phase change materials PCM is here. If we have using any kind of material, any kind of fluid inside a heat pipe, this must change materials, phase change materials using the cooling system. This is the main part of technology. So that is the clear about the technology of heat pipe. And next, that is the weak structure of heat pipe. Weak structure is I explain again. I showing here. Very clear copper pipe. Copper. This copper pipe is grooved, mesh, sintered. And I also here the mesh, weak structure, sintered. This is a we also use a different kind of materials. So before I showing that is the aluminum, this is the copper. We have to maintain make a method or model, what is specific use applications, and we should use that kind, make that kind of model to perfect solution of cooling system. And next, as said, the photography of sintered wick materials. That is the wick inside wick, the pore, and this is a size of pore, 50 micrometer, and this size. Based on this size, technology will be changed. The working fluid, working phase change, and everything will be very depend on pore size. And not only pore size, is also using what kind of materials we use for the wick structure. If we use the titanium powder, also we use aluminum powder, we also use the copper powder, and then sometimes we mix copper and titanium, copper and other materials, that we can getting the different size pore, and this is a main function of heat pipe technology. And next, I show you here the heat pipe inside the wick structure. The scanning electronic microscopy, the photography, you can get this picture. This photography can show us the different kind of size. This 100 micrometer. Also, we can get in some, like this is a 50 micrometer. This is 100. Also, the different metals and different size of the pore, the porous medius powder, wick powder, wick structure, the PCM we have applied to scanning electron microscope. This is SEM. Then we can get in the picture to analysis how will be better solution for cooling system. And next, we can get the numerical simulations for the sintered wick. And after getting the simulations, then we can get the result of how about the sintered wick structure. And this is the equivalent to diameter, the size of powder. And this is the cross-section area. How about the inside pipe? Have the materials is the sections, cross-section area. We can get in the curve, a circular powder, wick powder. Then we can get in the heat pipe, wick powder is here, and the result just showing the pioneer and the industrial cross-section area. These two issues we have to analyze and help us the numerical simulation for the heat pipe result, and how about my work is good or bad. And next, and that is the PCM technology. And this PCM technology, as we have explained before, the phase change materials. This is the liquid issue, the fluid issue, working fluid. The working fluid angle of inclinations for the vertical position. This issues is we have here the mesh 200, mesh 50, the different side. We just